Hello, everyone. Today I'm going to talk to you about how to electronify your Angular application, or in other words, how to run your Angular application in desktop with Electron. So what we're going to talk about today, first, we're going to see some of the internals, some of the basics of the Electron framework, then how to integrate an Angular application with Electron, and then how we can use a library that I have written, which is called Electronify, to remove all your burden and run your Angular application in desktop mode with just one command and no code. So let's get started. First of all, I would like to say some things about me. I work as a front-end web developer at Plexearth. I'm an Angular Google developer expert, and I'm also co-organizing a meetup just like this meetup at Angular Athens in Greece. I also work as a senior Angular instructor at CodeHub, a private educational institute, where we teach the Angular framework to other developers and individuals. Apart from that, I'm a huge Assassin's Creed fan. As you can see behind me, that I have the Assassin's Creed black flag. And also, I'm an author at Pact Publishing. Last year, I published my first book, which is this one, which is called Learning Angular 3rd edition. And it is destined for Angular, for developers that want to get started with Angular framework. And it guides you through from creating an Angular application from scratch using the Angular CLI up to deployment. It contains also a bonus chapter that showcases how to build a real-world application using all the knowledge that you have acquired in the previous chapters. You can find it in Amazon and in the Pact website. But today, I'm very, very happy, super happy, I would say, that I would like to announce my second book, which is available to pre-order and is called Angular Project, 2nd edition. It is destined for intermediate and intermediate level Angular developers that want to move to the next step with Angular, and it showcases how to use the Angular framework with 10 different cutting-edge technologies and modern tools. For example, it contains server-side rendering, monorepo architecture, NGRX, of course, Electron, Ionic, and many, many more. So if you're interested in a book like this, I have put a link in this slide. It is a Google form that you can fill in and get notified when the book will be available for publishing. We estimate to be around May or June. So let's get started with the funny part of the talk, which is Electron. What is Electron? Electron.js is a JavaScript framework that you can install using the npm registry. So you just type npm install Electron and you get it. Now, in the install command, you add the -d switch because Electron is not needed during runtime of our application, but only during development. It actually bundles our application into a desktop shell so that we can execute it later. It is used to create cross-platform desktop applications with web technologies, JavaScript, HTML, and CSS. It is built with Node.js and Chromium, and that is why we can write web applications on top of that. And the big advantage is that you can leverage your existing web skills and create desktop applications without learning a new language, for example, C# or C++. There are many, many popular applications that have been built with Electron. The most known are Visual Studio Code, Slack, or WhatsApp. In the Electron website, there is an extended list that you can check out, which contains a ton of Electron applications. So let's discuss a bit about the architecture of Electron. Electron consists of two processes. The main process, it is responsible for creating heavy tasks and calculations, for example, when you want to interact with the file system. And it is that process which provides access to native resources using the Node.js API. The render process is responsible for the user interface of your application. It manages the user interface, and you can think of it as a single index.html file that contains all your application assets. Electron follows the multi-process architecture of Chromium, and that is the reason that an Electron application can have only one main process that can communicate with many renderer processes. Each renderer process operates in complete isolation. So if we want to communicate from one renderer to the other, we need to go always to the main process. Let's see how we can create an Electron application. An Electron application is just a JavaScript file. For example, a main.js. We tend to name main.js because we usually name Node.js applications like this. So to create an Electron application, we import two artifacts from the Electron npm package, the app object and the browser window object. The app object, you can think of it as the browser. It is a global object of our application. And the browser window is the actual window that we load inside the app object. It is like a browser tab, for example. So you can understand that an app object can have many browser windows. So when we want to create a browser window in our Electron application, we call the constructor of the browser window class, and we pass some options. For example, here we pass the width and the height to set the size of our window. Then we call the load file method of the main window, passing a single HTML file that contains our application assets. This function, create window, we call it when the when ready promise of the app object has been resolved. And we do it like this because we need to make sure that we can create the window after our app is ready, has been bootstrapped. So if we want to take a high-level overview of an Electron application, we can think of it as an ice cream. Okay, the bottom of the ice cream is the main process. So if we add our renderer, which consists of HTML, CSS, and JavaScript, which could be the top of the ice cream, then we get an ice cream. An Electron application. So what's going to happen if we take the usual HTML, CSS, and JavaScript flavors and we put Angular flavor inside? Then we will have a hybrid application, hybrid Electron application. But what will be the output of this wedding, as Pato said before? Let's see. The most interesting part is the build. How do we orchestrate the build process between the Electron part and the Angular part? So first, we take the Electron code, the main.js file, we pass it through Webpack using a Webpack configuration file, and we export a single file called cell.js. We name it cell because we think of Electron as a cell for our application. At the same time, we take our Angular code and pass it through the Angular CLI using ngBuild. And of course, the application bundle is called main.js. Now, these two files are kept in the same folder, inside the dist folder. After that, we can use the Electron npm executable to pass the cell.js file that we have created and open our desktop application. Okay, so we saw how simple it is to create an Angular application, how it works when we want to integrate Angular with Electron application. Let's see now how we can communicate between the two processes of the Electron application, the main and the renderer. There is a mechanism which is called interprocess communication, or IPC, which is asynchronous communication, it is an asynchronous communication mechanism that allows the two processes to exchange messages each other. So imagine that we have two interfaces. The first one is the IPC main, which resides in the main process, and the IPC renderer, which resides in the render process. They can communicate only via a single channel. Usually, the IPC main process, it is in our Electron part of the code. And the IPC renderer, it's in the Angular part of the code. Of course, if you write only native Electron applications without any framework installed, both processes could have been in the same Electron code. Let's see how this can be done in an Angular application. First, let's see the main.js that we saw before. Here, the only difference is that we import the IPC main artifact from the Electron npm package, and we use it later on to attach a handle method here to call the handle method that it is like adding an event listener. Okay, so the handle method takes two parameters. The first one is the name of the channel that we want to set up so that we can communicate with the other end. And the second parameter is the function that will be called when someone sends a message to the pirate's channel. So in this case, we just return a list of pirate names. Please notice that in order to work also seamlessly between the IPC main and the IPC render interface, we need to enable the node integration flag, which is inside the web preferences option of the browser window constructor. Actually, this switch exposes the Node.js API in the window object so that we can use the renderer in the Angular code. So that was the Electron part of our code. Let's see the Angular part. Here we have created an Angular service, a standard Angular service. We use an Electron service. We import the Electron service, which is a service from a library called ngX Electron. The ngX Electron library is a wrapper API, a wrapper library over the Electron API. Then we inject the Electron service into the constructor of our service. And we have created also a method getPirates that uses the Electron service, and specifically it accesses the IPC renderer object from the Electron service and calls the invoke method, passing the same channel name as the one that we set up previously in the process. The invoke method returns a promise. So the communication between the main and the render process is promise-based. So you can use async await with no problem in this type of applications. So that was a really small part of how you can integrate an Angular and an Electron application. There is more of it. I have put a link to my GitHub, to a GitHub repository in my profile that explains all the process, and you can dive into this. But instead of doing all this that I described you can just use a library which is called ngX Electronify that I have created, and it takes all the burden from you, and you don't need code. So you can install it using the add schematic of the Angular CLI, which is ng-add ngX Electronify. So I will show you now how we can use it in an Angular application. So I will switch to my Visual Studio Code. Right. So here we have an Angular CLI application. Nothing complicated. I just made an engine and I haven't touched anything. I have only installed the ngX Electronify into my Angular CLI workspace. So if I want to run this Angular application in desktop mode, I just need to open the terminal and invoke the command ng-run, the name of my application, which is my Angular, and the name of the builder, which is called desktop, because ngx Electronify is actually an Angular CLI builder. So if I run it, and I hope nothing bad happens, we will see our application running in desktop mode soon. I will open also the same application in a web mode. Okay, let's see first the web mode. This is the Angular application. Nothing special, it's just the skeleton application of an Angular CLI app. And on the left, come on. On the left, we have the desktop application, which is rendered inside an Electron window. You can see here that there is, let me make it bigger. Okay. Come on, you can do it. Right, so you can see here that it contains a menu. This menu is for the Chromium that there is inside the Electron application, because I said at the beginning that Electron runs on Node.js and Chromium. So this window that runs our application is a Chromium. So we have all the good stuff of Chromium, such as developer tools. Right? Here you can see the code. You can inspect the element and all stuff like that. I mean, you can use it for debugging also. So if I make, now the good part, the funny part is that if I make a change to my code, say for example, I open my HTML and let's change the title to ngLeipzig. No, that's not correct. Leipzig. Okay, I saved my change. The Angular application recompiles, as we know, and if we go to our application, the web has updated its name, and the desktop has also updated its name. So one other benefit of the ngx Electronify library, except of running your application in desktop mode, is that you can run your application in different viewports. So you can use it as a debugging tool or when you're prototyping something. So let's get back to the slides. So that was the library that I was talking about. Now for the future, in the next version, we have some upcoming features that we want to enable. The first one is we want to support more configurations from the Angular CLI configuration, because now it runs only the serve mode. So we want to be able to run the build mode or the test mode, for example, because you may want to run your tests inside Electron. Then we want to implement the ng update so that the update of the library is seamless to the user, integrate some Chrome extensions so that you can make better debugging, for example, install Augury inside the browser window, Our biggest issue is, our biggest feature that we want to roll out is to export your Angular application as a single executable file, because the window that you see now is just a preview. Okay, it runs in development mode. Currently, you can't take your application in desktop and go away. So we want our users to be able to export it as an executable file. And then we want to find a way for interacting with the Electron API. So you write, this is part of the communication between the main and the render process that I was talking previously. For example, we want you to be able to write the code for the IPC main and the IPC renderer communication by yourself, which now is practically not feasible. Right, so Electron, as you can understand, is a web page, is a browser, right? No, it's not a browser. It is like a browser. It is not a browser, but acts like it. We must never forget that an Electron application is a web page. So every security problems that exist in the web world exist also in the desktop world of the Electron. Electron is not a browser. Okay, so you have to take some security precautions by yourself when you develop, because a browser, for example, Google Chrome, has some security I mean, it prevents you, it has security built in, so it prevents you from doing bad things. But Electron, it may look like a browser, but it's not. So you need to put the security considerations by yourself when you develop your application. In the next slide, which is the resources links, I have put a link about security best practices. So here is some resources that I think it may be useful to you if you want to create an Electron and an Angular application. I have put the security best practices, how to secure Electron applications. This is a talk that I did in the WebRAS podcast. The WebRAS is the Real Talk JavaScript podcast. And also a link to the NGX Electronify and my Angular Electron sample, which is more complicated. So, what did we see today? As a recap, we saw some of the basics of the Electron framework. There are many, many more, but we can't cover them all in a talk. We saw how to integrate an Angular application into Electron and what we should take into considerations, for example, the build process. And then we saw a demonstration of the ngX Electronify library that you can use to run your application in desktop mode without writing a single piece of code. So thanks very much. I really enjoyed this presentation. I would be happy to answer any questions that you may have.